Sir, I think you are mute.
Hello.
Yes.
Is it audible?
Yes, sir.
Yeah, now it is
Yeah.
audible.
Yes, sir.
Yes, yes. Samir is there. Suleika madam is there. Masroor is there. Yes, all of you are there. So, shall we start today?
Yes,
Hello.
sir.
Yes, sir.
Yes, sir.
Okay. Yes. After I think 15 days, I'm joining you again. You were going through, I think, that AutoCAD sessions, no?
Yes, sir.
Yeah.
Yes.
Okay. So कुछ भूले तो नहीं ना बीचला?
No, sir.
Okay, okay. Then let us start today's session and let me present what. Oh, हमेशा बोलता हूँ. So I am presenting now. It must be visible to all of you. My screen is available to all of you. Hello.
Yes, sir.
Yes, sir.
Yes,
Visible.
yes. Okay, okay. Then let us move to straightway to this. Okay, so today we'll be going for basic understanding about SAP software. So SAP icon will be something like this, and double click on it, and okay, you can see that SAFE, and what it stands for. Anybody? Hello. Anybody knowing the long form of SAP? Yes, I think I am not audible. Hello.
No, sir, you are audible.
You are audible, sir.
Okay, so anybody knowing it? Try to manipulate how you can do it. See, S stands for slab, A stands for analysis, slab analysis and design with the help of finite element. So SAFE. Okay,
Okay, sir.
is it clear now?
Yes, sir.
Yes, sir.
Slab analysis and design by finite element method. So that means entire will be whatever. See, you will develop your model in ETAP, and you will analyze the model, and you will design columns and beams, and for footing and slab, you have to take the help of SAP. Okay, if we are only relying on CSI softwares. So ETAB, it's a very similar to ETAB. So if you know the ETAB, you can find out it very comfortable, because everything is just like ETAB. You can see over here. So there are two windows, and you can see the toolbars or drop down. So this is again, you can check it as a drop down. So first you have to go to file, click on file, and click on new model. Now actually you can import the your ETAP model, analysis of ETAP model in SAP, and you can go for all design of footings and combined footings and strap, mat, etc. But just we want to go through the basic. We'll be creating the model of the footing. So today we are concentrating on isolated footing. Clear? Hello.
Yes, sir.
Yeah. Now you can see this is the first new model initialization template, or you can say dialog box. And now this dialog box, you will have to fulfill the requirements. That is which design code you are going to use. definitely we are going to use IS 456 2000. Then what current units that you are going to use? You are going to use metric units. So you can, by default it is metric, but if it is not something else, then you have to go for metric. And then you can go for this design preferences, click on this and see that IS 456 1.5 for gamma steel, 1.15 for gamma steel, and concrete gamma is 1.5. That is okay. Then you can go for here minimum cover slab. So in slabs, we are going to design only footings. So we'll be going to see this only. So post tensioning and this we are not going to use. So here, what is the minimum cover that you are going to use for footing? Definitely 50, top and bottom. Okay. Now you can go for your preferred bar size, and later on you can change it. And this is layer B and layer A that I will introduce you when we will be drawing. Okay, and click OK over here. Okay, is this much clear?
Yes, sir.
Yeah. Now you can see your model initialization has been completed, and now already there are various types of templates. That means if you want to start from scratch, you can go through blank. Otherwise, you can go for flat slab. You can go for perimeter beam slab, two-way slab, base mat. These are ready-made templates, but you can start with this. So we are going to start with basics. So we are going to create everything uh, as per our requirement, and then we'll be using 1 minute, just. Okay. Actually, I am not a little bit feeling not proper, but okay. Let us start. Hello. Yes. Are you there?
Yes, sir.
Yeah. Now you can see. First, as usual, we'll be going for define. So click on define and click on materials. Okay. Now again, you have to go for defining materials. That means we are going to define concrete and reinforced material. So add new material. Here name of the material. Now you can say any name, but I will use name of the material as footing, because I'm going to use it for footing. So the name of the material is footing. Type of the material is concrete. Okay. Then you can see here uh, now this version is a lower version, because up till now CSI has not updated this. So wet per unit volume and modulus of elasticity, coefficient of thermal expansion, that you have to provide on your own. Okay. So what is the weight of unit wet per unit volume for concrete? 25, right? And on the right side you can see the units. So units are in kilonewton per cubic meter. So the weight of concrete is 25 kilonewton per cubic meter. And what is the modulus of elasticity? Let's say we are going for concrete grade of 20. Then what is the modulus of elasticity? Yes.
So 5000 root FC.
Yes. 5000 5000 root FCK is your answer, and that answer is correct, but it is half correct because you have not mentioned units, where FCK is in Newton per mm square. So this EC will be in Newton per mm square, and exactly you can see here it is Newton per mm square. So you don't have to convert that thing, right? So what is the value? Either you can type it or you
So
can
22360. It's something.
uh, uh, 22360.680, but
Yes.
and if you do not remember it, not no problem. You can type this formula, and how you can type it as 5000, then star, that means multiplied. Then I will make a bracket, and I will use M20 as FCK, and I will square root it. So square root is that sign plus into 0.5, right? Clear?
Yes, sir. Sir, it's
And then
500. We have to 5000.
yeah, it has to be 5000.
Yes.
Has to be 5000. You are correct. Okay. So 5000 under root FCK, and I will enter, and I will get the exact value. And now you can see it is 22,360.679, etc., etc. You can make it as at 0, right? Or you can leave as it is. Then Poisson ratio, obviously 0.2. Now this coefficient of thermal expansion, actually by default they are saying 9.9 e raised to minus 0.6, but actually it is 5.5. For in Indian standards it is 5.5 e raised to minus 0.6. So you can overwrite it as 0.12345 and 55, and enter. You can get it, and now you can see that it is 5.5 e raised to minus 6, means 10 raised to minus 6. Clear?
Yes, sir.
Actually it is not used because we are not using coefficient of thermal expansion in any of our formulas, so it is not required, but it is always better to know the exact value that code has specified. For concrete it is 5.5 10 raised to minus 6. So that is what we have written. And FCK now will provide FCK as 20, and it is not lightweight concrete, so we'll make it unchecked. And you can see here program modulus of rupture, etc., that is defined by program default. You can keep it as it is. Click OK. So here you have defined. Okay, here I will provide name of the material as M20, and let me modify it. So not footing. Footing is after some time. So M20. Okay. So the name of material is M20. Then I will go for add new material, and now I can go for HYSD or FE415. So I can say FE415, and then it is a rebar. And now here you can check it as 7.69 e raised to or 10 raised to 1, or you can say it 7.8 as per your choice. Normally it is considered as 7.8, or you can say 78 kilonewton per cubic meter, which is a weight per unit volume for concrete. And I mean reinforcement, and modulus of elasticity is 2 into 10 raised to 5.
Two. Yes, sir.
Yeah. So 200, and then 1000. 1, 2, 3. So that you can provide it over here. Now this FY, as per, if it is 415, then you will apply it as 415. And uh, actually this is not required, we are not using it, but this is a tensile stress or maximum tensile stress that it can be, this FY can use, and it is something around 5 to 10% above, and for 415 it is something around 485. And you can check the units, Newton per mm. So everything here is in Newton per mm square, and density is in kilonewton per cubic meter. Okay. Uh, in ETAB, it was automatically given by default, and we just have to check it. But in SAP, you have to provide it manually. Clear? So the material has been defined. Then go for define slab properties. Now, what slab property that you are going to use? You are going to use the slab property for footing and uh, column, which is in the footing. So add new property, and here I will call it as footing. So double P N Z. You can say footing. Then here the material will be M20, right? I think 415 is not saved. Let me check it. Define materials. Yeah, it is not saved. We have to save it. Add new material. So this is FE415, then rebar, then this is 78, and this is 200,000, right? 1, 2, 3, 4, 5. Then this is 415, and this is 485. Click OK and click OK. That was not clicked, and that's why it was not available. Okay. Then slab property. Here we are going to use a slab property. You can say slab 1, 2, 3, anything, but I will be using it as footing. So the slab property for footing material will be M20, and now here you can check the various the design types or analysis property data and click on footing, because this you are going for using for footing. And here approximate footing depth that you can define, let's say we'll define 450. Later on you can change when the punching shear is not satisfied. Okay. And thick plate. Okay. So thick plate by default it is there, you have to use it as thick plate, and click OK. So the footing has been defined. Another property for column is also to be defined, and that you can define over here as add new property. And now here I will say column. What will be the material? M20. And what will be the design? Now it is designed as step. Clear? Hello.
Yes, sir.
And depth will be as depth of footing. And so these are the two properties. Let me show you this. See, this is your footing. Let's say this is your footing. And let us say uh, this is your column. right? Hello.
Yes,
Yes.
sir.
Now,
Yes, son.
what is happening? This area, see, when the load is applied on this area outside this, area outside this. So this outside area, if you see the section, you will see it something like this. And this area outside is getting bent. But this area, because of the load coming from this, in plan this is the area, in elevation this is the area. So this area acts as a unit, and that's why it is considered as steep. Clear? This is considered as steep. Hello,
Yes, sir.
are you getting it?
Yes,
Yes,
son.
So that's why the property that ETAB has developed a separate property, and that is exactly that property that I'm going to show you. So if you go to column and see, it is a steep property, and you can check it over here. So a mat is a property, a ribbed slab is a property, waffle is another property, drop is another which is used for flat slab design, and normal slab. So these are the different properties that has been defined in SAFE, and that's why I'm many times people do not understand what is this tip. Yes, are you getting it? Hello.
Yes, son.
Yeah.
Yes, son.
Then we will go ahead. Okay. So we have defined material. We have defined a property for footing. We have defined a property for column. Now we'll define a property. Okay. Okay, I will define it and then I will explain you. Uh, yeah, define this soil subgrade properties. Okay, first I will define. Let us see how it is defined. We'll go and see. So I will use it. Soil. Now the soil bearing capacity that I'm going to use is 325. Okay, that's why the name I am saying soil 325, and instead of that bearing pressure, so 325 is the sub bearing capacity or sub bearing pressure that upward pressure that is developed due to the resisting area, that is the footing area. Okay, so here it is defined as subgrade modulus. Okay, and subgrade modulus is nothing but uh, 325 as shape bearing capacity multiplied by factor of safety. So what factor of safety that you are going to use? Let's say 2.5. Most of the time it is 3, but normally I go for 2.5 as a factor of safety that has been defined by geotechnical experts. Okay, so shape bearing capacity multiplied by factor of safety divided by allowable settlement that has been accepted by code, and allowable settlement for individual column footings is 25 mm. So I will write it in mm as 0.025. So whatever may be the value, that will be considered as subgrade modulus and compression only. And now enter. So you are getting uh, let me do it, 325 multiplied by 2.5 divide by 0.025 and enter. Yes, 32,500 kilonewton per cubic meter is the soil subgrade modulus, and click OK. And now I will try to explain you how it is working. Uh, yes, anybody knowing subgrade modulus? Hello.
No, sir.
Oh, actually, it's a part of uh, soil
The
mechanics.
reaction given by the soil if we are going for the plate load test.
Yes, yes, yes. So, but how that reaction will be given by this? Let's see. See, this is your footing, and you are having a column something like this. Now, because of the load on the column, because of the load on the column, whatever may be load and whatever may be moment, P and M, whatever it may be. So, because of that, this footing will be now it is resting on uh, a layer below. Okay, so below is a layer, so soil. Now soil is providing upward pressure based on its bearing capacity, right? It will be exhibited something like this. But it is not a homogeneous material. Soil is not homogeneous material, right? So because of that, some settlement is allowed, and there is a settlement. That's why we considered it as a spring. We considered all these as a spring. Are you getting this idea? So these instead of the, so this is a spring. So the spring has some effect. So that is that subgrade modulus K, and it is referred as SBC. Okay, multiplied by factor of safety divided by allowable settlement. So settlement. Okay. Now, how you are defining SBC? Kilonewton per square meter, right? Hello.
Yes, sir.
Multiplied by factor of safety. What is the unit of factor of safety? Unitless. And divided by meter. Settlement in terms of meter. Uh, this is not kilonewton per square meter. So SBC is in kilonewton per square meter and divided by meter. So finally, you will get value of K, which is soil subgrade modulus, Ks equal to a unit will be kilonewton per cubic meter. Right? Clear?
Yes, sir.
And this is the value. That is a spring stiffness. Spring stiffness. You can see always springs when you are pressing the spring, there is some settlement, and then the spring will act to resist that force. Clear? Hello.
Yes, sir.
Yes, sir.
So that's why actually SBC SBC is indirectly given with this Ks, soil subgrade modulus, which is in kilonewton per square meter. And now you can check that. So let us go and see that. So define and soil subgrade properties. And if you modify show property, you can see that it is in kilonewton per cubic meter. Clear?
Yes, sir.
So depending on whatever SBC that you get, you have to convert it in soil subgrade modulus, and then it is to be provided as input in SEM. Okay.
Okay, sir.
Now we'll see. So we have defined subgrade modulus. Then we'll go for load patterns. And in load patterns, you can see already there are load patterns dead and live. And most of the time we are designing footings for uh, axial load only. So dead and live. So you can see for dead, self weight multiplier is 1, and for live it is 0.0, as whatever we have seen in ETAP. So it is same. So you don't have to define any other load, or if you want to define, you can define SDL, then you can define that EQX, EQY, and all that will have self-weight multiplier as 0. Okay. Now we'll go for combination. So what are load combinations? Add new combination. Let's say combination number 1 will be our service load combination, where dead load will be considered as scale factor 1, and here you have to provide live load and scale factor as 1, and you can check here, check this service normal. Okay. So don't so this is the working load combination. So it is used for serviceability criteria. That's why service normal is only to be highlighted and click OK. Then another combination will be your strength combination. So which is combination number 2, where you will have dead load as factor, scale factor will be 1.5, and then live load will be factor will be 1.5. Okay. And now you can go for strength ultimate. Now don't go for this service normal. So the first combination is for service normal. Second combination is for strength ultimate, and click OK. So these are the two combinations that are mostly required. Click OK. Now everything has been defined. Now it is a time to draw it. And now how we will be going to draw it? Go to draw. So click on draw, and you can see various things, but right now we'll be using quick draw areas around points. Okay. But before that, you must have your data for your footing. So let us say that I'm assuming the data as dead load equal to 600. Okay. Live load equal to 230. I'm just assuming some arbitrary. This will be as per your analysis. Okay. So this will be in kilonewton, and this will be in kilonewton. And now this is working load. Don't go for combination loads. So these are the primary load case results. So dead load on one footing you are getting 600, and live load you are getting 230. SBC, that as you know that we have assumed as 325, 325, that we have converted for KS. So 325 kilonewton per square meter. Okay. Then the dimensions of the column that I am considering as 230, and D I am considering 530. And these units are in mm. Never ever provide anything without units. So these are the basic data that I am assuming. So the dimension of column is 230 by 530. The loading on the footing from the column is 600 as dead load, 230 as this, and then you will see that approximately if you calculate the size, then you can see length of the footing that I am considering as 1.85, and width of the footing that I am considering as 1.5. You can check that this is sufficient, and then you know that depth of footing already right now we have considered as 450, and if it is not sufficient, then we'll increase it later on, right? So this is the data that I am considering for drawing the footing size and column size. Okay, any doubt? Hello.
No, sir.
Now you will get all these data. Either you can go arbitrarily for practice, or you can get your analysis results from your ATAB, and whatever dimensions of columns and dimension, based on that you can find out approximate LF and BF, and you can check whether it is satisfactory or you need to increase. How it can be increased, that I will show you. Okay. Okay. So I will now you people will let me know the dimensions later on. So this is the data that we are going to work. So click on draw. Then you can see here various draw options, and in that I will go for quick draw areas around points, because I know here a origin, so I can draw the area around this origin. So I will use this quick draw area around points. So click on it, and now you will get one window where you will see that type of object is slab, shape of the object is rectangular, and property, first I will go for footing, and what will be the dimensions of footing? That is 1.85, which no, in x direction, yes, you can go for in x direction as 1.85, and in y direction as 1.5, or you may change it as per your choice. Okay. So 1.85 and 1.50 are the dimensions that I'm going to use for footing for my preliminary design. Okay, clear?
Yes, sir.
Then if you go to this, you will see that origin is clicked, and click on that point. You can see. Okay, we'll use a vertical. So I will do it in another manner. So let us move it and draw area around points, and here I will go for 1.5 in x direction and 1.85 in y direction, and then I will click on this, right? So
Yes, sir.
I have drawn a rough size of footing, and then I will go for this. I will change it as column. Now I am going to draw the column, and what are the dimensions of column? Now in x direction I must go for
30
width,
mm.
which is 0.23. See the units over here,
Okay, sir.
otherwise you will make a horrible mistake. So in y dimension it will be 0.53. Okay. So 230 by 530 is the dimension, and now again I will click on this. Clear?
Yes, sir.
So this is my footing, and this footing is supported. Okay, actually I have not gone into that. Okay, and always go to this select object position. Otherwise, it will go on drawing wherever your pointer will click. He will go on drawing the column over there. Now you can see this is your footing, and this is inside area is your strip area, and that is for column. Now I want to assign the SBC. So how I can assign? I can click inside this footing, but outside the column. So click on that. So you can see a green line appearing over here, and you can check here. One area and four edges are selected. That means you have selected only footing, and then you can go to assign. Click on assign and go to support data, and under support data, you will click on soil properties, and soil properties, this is your 325. That is the soil property that you are going to assign. Now you can see the springs are attached. Green dots crosses. Do you see it? Hello.
Yes, sir.
Yes. Hello. Can you see that?
Yes, sir.
Yes, sir.
Yeah. Now, if you want to check it in 3D, you can check it like this. So now here you can see. So this is the springs that has been attached on the periphery of the footing, and that soil 325 is the property that recently you assigned. And now if you want, you can go and clear display of assign. So that 325 is removed, and you can see it. Okay. So this is your 3D. Otherwise, you can go to horizontal as XY, and now you can see. Now what is the thing that you have to assign? The loading. Okay. Hello. Are you getting it?
Yes, sir. Yes, sir.
Now I have to assign the loading that is to be registered by this footing through this column. So here you have to draw the point, otherwise that loading cannot be assigned, because now you are going to assign dead load and live load, and that is a concentrated load. Actually, it is distributed all over the this column, but it is assigned over here at the origin. So you have to draw the point over there. So for that, I will go to draw, and under draw point option, I will click on it, and you can see here these are the offset dimensions, but I don't want any offset. So where I will click, the point should be drawn exactly that. So that's why you can see here 0 0, and then click on this, and now you can see the line over there. So that is the point. Okay. Now after that, again you have to select it. So click on it so that it is selected. Now you can see the cross has been selected, and you can see here one point is selected, and then you assign the loading. So how you will assign? Go to assign, click on assign, click on load data, and under load data you will go you will go to point loads. So click on point loads, and under point load you will see that there are the primary load cases. Right now here only two primary load cases we have defined. So under this, in gravity minus z direction, you have to provide value of your dead load that you got. So that is 600 kilonewton, right? Means you can assign a load in x direction, you can assign load in y direction, you can assign load in z direction, that is minus z. Then you can also assign mx, my, mz. That you can do I'm just showing you. That's why I'm going to assign only dead load in Z direction and replace existing load. And now this is very important. So if you forget to provide dimension over here, then the punching shear calculation will not be calculated. Okay, so these are the dimensions of your strip area, and that means our column. Now in column, we can see that 230 is in horizontal direction, x direction, and 530 in vertical direction. So I will write, now I am saying 230. Now I am not saying 0.23 because outside it is okay, 530. Clear? Hello.
Yes, sir.
Click OK. And now if you go to 3D, you will see the load is assigned. Check that it is applied properly. Okay, so the load is directed downwards. You can see Z axis is upward, but load is directed downwards, right? Then again, go to this, then assign, clear display of assign. Now again you have to click on that point. So the point is selected, then you will go to assign, and in assign load data, under load data point loads, and under point load, now you will select the case as a live, and loading that I'm assuming as 230, then replace 230 and 530 are already there, so I don't have any problem. So I have assigned the load data. Now if you want to check this load data whether it has been assigned or not, you can just clear, and then see, right click on exactly on that point, and then go to load, and you can see over here under dead load category you have applied 600, size is 230 by 440, 530, and under live load category you have assigned a load of 230. Clear?
Yes, sir.
But if you do not correctly click the that point and click somewhere here, and if you go, you will see in loading is there is no loading, and this is many times confusing to people. They select the column and try to see the loads, and they don't find the load. Actually you don't have to select the column, you have to select the point, and then you can go and see the loading. Clear?
Yes, sir.
Yes, sir.
Okay, so we have done everything. So the footing dimensions, if you want to check the footing dimensions, you can go to draw, and then draw dimensions. So draw dimension line, you can check whether the dimensions that are correct. So 1.85, it is okay. Then again, I will go and see the dimension line, and this as 1.5. So okay, so accordingly you can check your entire work before going for calculation. Now what is remaining? Anything remained? We have applied the dead load, live load, we have defined column, we have defined footing size, we have defined depth of the footing right in the defined material properties. Then we have assigned support data, so everything. Then we have also defined the load combinations, service load combination, ultimate load combination, or strength combination. So we have to just go for run analysis. Click on run analysis and design. Now it will ask you to save. You can save somewhere, so I will save this same file. Okay, so after saving, he will display the result. Now this is the result. So you can see displacement dead but we are not interested in that. We are interested in knowing whether the allowable settlement has exceeded or not. Clear? So how much allowable settlement that we have assumed? 25 mm. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now you have to see whether that allowable settlement has exceeded or not, or the actual settlement has exceeded the allowable settlement or not. So you have to go to display, click on display, go on show deform shape. On deform shape, go for load combination. Under load combination, you know your service load combination, and allowable deflections are always checked for service load combination and not for uh, strength load combination. So the combination number one is to be selected and apply and then close. Now you will see sir यहाँ तो कुछ है या नहीं है? See, he has given you the pattern, and you can see for isolated loading conditions, the pattern will be just like this, because a settlement will be heaviest at the center point because there is only one point, and remaining part is cantilevered. So the settlement will be always heavier below the column, and you can see here a bar chart, or you can see classification. So various colors will show you various deflection settlement in mm. So highest you get it as 9.68, but if you see a color over here, you can see something around 9.64. So it is well below the allowable settlement. So the allowable settlement criteria has been passed by this size. Clear?
Yes, sir.
Yes, sir.
Now, the next criteria is that whether the bearing capacity has been exceeded or not, or the actual load have exceeded the bearing capacity limit or not. And that you can check again through display, show reaction forces. So click on show reaction forces, and under that again load combination will be combination number one. And now you will, instead of this, you will go for soil
Soil
pressure.
pressure.
Okay, and in
Yes,
that
sir.
soil pressure you just apply and okay. Now this is a pressure distribution diagram, and you can check it, and you can see over here the maximum is something red, and it is something around 314. And what is our allowable bearing pressure, or SBC, that we have assumed? 325. So it is almost near. Now if you want to increase that, then what you will have to do? Hello, you want it, see, actually the bearing pressure that we have calculated is just reaching that. So we are saying that 325 is the maximum bearing pressure that can be allowed as per foundation consultants report, and now we are at 314. So there is a little factor of safety. So if you want, you can increase the size. Only after increasing the size, you will get the lesser bearing capacity, soil pressure. Yes or no?
Yes, sir.
Hello.
Yes, sir.
So for that, what you have to do? Unlock. Results will be removed. Now you can say that you can increase the size of footing by some. So right now it is 1.5 by 1.85. So you can go for say 1.9 by uh, 1.65. So 10 mm. Hello,
Yes,
hello.
sir. Yes,
Are
sir.
you getting it? So it is
Yes,
1.5.
sir.
I just want to increase it by 100. So I will select it, right? Uh, Select. So one area and four edges are selected. So I have selected only the slab, and then I will see somewhere here. So edit. Under this edit, you can check out edit areas, and under that expand or shrunk the areas. So click on that, and now here how much you want to increase? By 100 mm, right?
Yes, sir.
Yes.
So 100 mm total means 50 mm on left, 50 mm on right, 50
Right.
mm on up, and 50 mm on bottom. So you can provide it with that. So let's say I'm going for expanding it as 50 mm. So if I provide a positive value, then it will expand, and if I provide negative value, then it will shrink, right? You can check it. Click OK. Increased. Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes. Any doubt?
No, sir.
Okay. Then again, you can go and run analysis. Now you know that settlement is no issue. So what you will go? You will check your soil pressure. So show reaction forces under soil pressure. Combination number one, apply and close. Now you can see that the maximum something around 281. So yeah, it seems okay. So whatever see, when you want to pull down the pressure below, then you have to increase the area, and the same will happen with the settlement also. But most of the time settlement is not at all big issue. The bearing pressure is, see, if you have not chosen the size right in the beginning uh, with any other thing, then that could be a issue. Okay, so now it is okay. Now what about uh, that two-way shear? So again, you can go to display, and now you can go for punching shear. So click on punching shear, and you will see that you are getting punching shear ratio something like this. Now this is the ratio that I will explain you something like this. Okay, actual actual force, or let's say actual stress divided by allowable allowable stress. So this is the ratio. That means if it is less than 1, it is okay. And if it is greater than 1, then you have to revise DF. Depth of footing is to be revised. Right? Yes.
Yes, sir.
Now,
Yes, sir.
now let us see that what is this 0.65 means. You are having 35%. So 0.35 is your factor of safety, because anything less than or equal to 1 is okay. So if even if this comes out to be zero point 0.9, then as per our calculation or theoretical concept, we'll say that it is okay, but it is just very near. So I will say that try to try to create this something around zero point 0.8 or 0.75 to 0.85. 0.85. Right? And how that you can define. So right now it is 0.65, and I have provided a depth equal to 450. That means there is a scope for me to reduce the depth of footing. Are you getting it? Hello?
Yes, sir.
And if it is say 1.05, then that means that means uh, it is greater than 1. That means it is failing. So I have to increase the depth of footing. Right now this is a standard that I feel, but you may say, sir, okay, we are happy with this, so then it is okay. But if you want to minimize depth of footing, because we how we have considered depth of footing just by some arbitrary assumption, no? Yes.
Yes, sir.
Now let us see that. I will give you a trial, so that let's see what happens if I reduce the depth of footing. And how I can reduce the depth of footing? Very simple. Unlock it. पहले तो अनलॉक करना पड़ेगा. Okay. Then after unlocking, I will go to define, and in slab properties, I will go for column, modify show property, and here I will mark it as 400. Then footing also I will mark it as 400. So footing and column, both depth of footing and depth of column, they are same and they are revised. So we have reduced, and then again we'll go for analysis. So run analysis. And now we'll be going for display, show punching shear. Now you can see it is something around 0.80. Okay.
Yes, sir.
Now, if you want to see the details, just right click on it and you will get the entire details. It is taking a little bit time. So these are the punching shear calculation. Now you can go through all these punching shear calculations. I think you know these things very well, how a punching shear, and finally you can see this punching shear ratio 0.80, which is a maximum design stress divided by concrete shear capacity. So 0.835 divided by 1.044 will give you something around 0.8. So all that calculation is shown over here. You can just go through entire calculation, and so that your manual calculations will also, you will get much more confidence. You can see how average effective slab thickness has been calculated based on your total depth of footing as 400. So it has been calculated 338. Then effective punching perimeter, the punching perimeter. Uh, that is uh, b plus 2d, right? D by 2 on this side, d by 2 on this side, b plus d and d plus d, so that you can find out the punching perimeter. Then the cover, then concrete compressive strength is 20, that you know. Reinforcement ratio is not taken into consideration. Then moment section in inertia about I2 to I33 is calculated. Based on that, MU2, MU3 are also calculated, and shear force is calculated with the help of your analysis. So 640.384, unbalanced moment, and then maximum stress this. So you can go through all this, and you will find it helpful for you for calculation of punching shear and design. Okay. So right now, if you are interested to go through that, or if you are only interested with that, okay, it is less than 1, I don't have to worry, it is okay, then you can say okay. Now everything, so we have defined the sizing, we have defined depth, and we have checked that it is effectively, so punching shear is no problem, this settlement is no problem, and bearing pressure is also no problem. Now we will be going for design, reinforcement design, and how that reinforcement design is carried out. Again, you will have to unlock it. See, I'm going through entire basics. The people will not give you this detailed understanding. Uh, anyway, now, if you want to find out the reinforcement, normally design strips are to be drawn, and those design strips can be drawn. Uh, okay, so how I can show you? See, normally when you are having, let's say, this is your column and this is your 14. Let's say this is B. Let's say this is BF or B. Let's say BF and this is LF. If you go through book says that this is one strip and the width of this strip. So if I call it as B, so B is equal to
BF.
BF by 4. So actually, this is BF by 4. Normally, BF by 4. So this is the area of reinforcement where you have to provide maximum bending moment. So maximum resistance is to be provided in this area, and remaining area you can provide half the reinforcement. That is what the book says, and the same thing happens in this direction also. So this is your area where you have to provide uh, more number of bars, and in remaining area in this and in this area you have to provide lesser. But for simplicity, we go for entire area for the same reinforcement. Maybe you say 12 tor at 125 center to center. Let's say when you say that it is 12 tor at 125 center to center, that means you are providing entire width with a reinforcement as 120 12 tor at 125 center to center, right? For entire width. Okay. Theoretically, it has to be central part. Edge parts will need lesser moment. Clear?
Yes, sir.
ऐसा ही होगा ना. See what will happen. See, if you are having this column, you are having this bending moment, this footing. This much area will be subjected to heavy flexural stresses, and this area will be subjected to lesser flexural stresses. Yes.
Yes, sir. Yes, sir.
So theoretically you should provide more reinforced bars in this area and lesser spacing of the bars in this area and this area. But we say whatever is the reinforcement required in this area, we provide it for entire area, right? Clear?
Yes, sir.
Yes, sir.
Now, this is when this is to be defined for software. Software will not understand your design process. Software will understand in terms of some assumptions. So, software, what we do, we provide the uh, a strip. So, so what is the area right now? So, if I go and see, uh,
Sir, your voice is not coming.
Yes, sir.
Sir, you are not.
So you are not audible, sir.
Hello,
Yes, sir.
am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
I joined.
Yes, sir.
I left the meeting and joined again. That's why it is. I don't know what happened. Okay. Let me open it. So isolated footing. Okay. Let's see whether we have saved it. No problem. आवाज तो आ रही है ना? Hello.
Yes,
Yes,
sir.
sir.
Okay. So we were talking about that
Sir, you
strip.
have not shared the screen.
ये ऐसा होता है जल्दबाजी में ही. Yes. Now I think screen is shared. Hello.
Yes, sir.
Yes, sir.
Yeah. So we were over here. Okay. So we were talking about drawing a design strip. So for that, what you have to do, you have to go to draw, and in that draw design strips. And here you can see this. This will be one. This will be one because it is 1.95. So I am saying it as 2 meter. So half of that will be 1 meter, and I will draw a strip from this point to this point somewhere, or you can draw exactly at putting this midpoint also. Okay, and then enter. Okay, so the strip is drawn parallel to x-axis. Similarly, you have to make it as a strip B, and now this will be 1.8 means it will be 0.9, right? Yes. Hello. So this is a strip that is parallel to y-axis.
Yes, sir.
Yeah, and put it entered. That means you have drawn the strips. Now, after drawing the strips, you can go for design, and then he will give you the reinforcement also. Just let's see how the strip will look in the directions. So go to view. Under view, you can go to set display options, or you can immediately go to this also. And here, show width. Under design strip objects, you can go to show width and click OK. See, this is how you are using it as a design strip. Okay, so the entire footing um, is say has been covered with the strip, right? So go to view, set display options, and then make it this. Okay. Okay. So now then you can go to run analysis and design. So it has been designed and you get it. Now go to display and now go for show strip forces, or you can go for show slab design directly. So click on slab design. Now there are bases that either you can go with finite element based or strip, but we have drawn strips, so we'll be using strip base. First, we'll see the layer in area A, and then you can check it rebar location at top and bottom, etc. Then this is a show rebar intensity area per unit width. So whatever rebar will be area will be shown per meter wide. Okay, and then you can use this and just apply and close, and you will get this. So you can check it. So the maximum will be somewhere here. So how much it is coming out to be? 9 foot, something around 935. You can check it 935, or if you want to see that, show strip forces slab design, and you can go for show values at controlling sections on diagram and apply close. So you can see that here it is something 962, right? So 962 area of the reinforcement is required uh, per unit width. So if you are providing say a 12 bar, so how many number of bars you will have to provide? So 962, you can check it, 962 divided by 113, because 113 is the area of bar of 12 dia. So 8.5 means you have to provide 9 number of bars in 1 meter. So how much it will be then? 1000 divided by 9, that will come out to be 111, right? So 111 will be your spacing. Now you can apply that, and you can see right now. You see here, you are getting area required. Are you getting this idea? Hello.
No.
So whenever I'm moving the cursor, you can see at every point he is asking me some area that is to be provided, because right now we have not provided any area. Clear?
Clear, sir.
So maximum that he is asking me is that 962 square or 963 square area is to be provided at the face of the column. So 962 divided by 113, because I'm going to provide 10 dia bar, 12 dia bar. Then you can provide it in this. Now instead of this none, you can go for typical uniform reinforcing schedule specified below. So here you will specify it. So 12 dia, and what area that 119. So let's say I will provide 110. Okay, and bottom, so top, actually top I don't need that, so I will say that top will be 10 and bottom will be 12 and 110. Okay, clear?
Yes, sir. Yes, sir.
Apply, close, and now if I see, I don't find any reinforcement. Everywhere I see 0 0. That means whatever area provided by me is now okay. Clear?
Yes, sir.
Yes, sir.
अगर इससे मैंने कम एरिया प्रोवाइड किया तो क्या होता है देख लो. तो डिस्प्ले, शो स्लैब डिजाइन. Let's say instead of 110, I have provided reinforcement of 12 dia bar, something around 140. Okay, and this also 140. Apply, close, and now if I go over here, see he is asking me, no, that is not sufficient. मेरे को और मांगता है. Are you getting it?
Yes, sir.
So
Yes, sir.
top he doesn't require, but at bottom you can see that he is asking you to provide the area. That is how you can check it. That's why initially I calculated that, and I have given you so 110, and this may be 100 and okay. So apply, close, and now what is happening? Yes, top and bottom. Let me do it again. Something was missing. Run analysis and design, then display, show slab design, and typical instead of that none, apply, close, and yes, that is. Then again display, slab design, typical, and 110 at bottom, 140, 10 at top, apply and close. Yeah. Now you can see that everywhere I'm getting 0 means whatever I have provided is sufficient, right?
Yes, sir.
Yeah. So this way you can apply it for your area in B layer also. So let us see how we can do it. So again, I will go for display, show slab design, and now I don't want A because now I want area in that and none. First I will go for none so that I will understand how much is the required. So you can see over here how much is required, something around say 949. Let's say 950, 950 over here. Okay, so 978. So let's say 1000. Yeah, it is more than that also. So it is 1022. So that means 1022 is to be provided in 12 bar. So 1022 divided by 113. So 9 numbers means I need 10 bars. So if I provide 10 bars, then I will provide 1000 divided by 10 bars, so 100. Okay, so I will provide reinforcement in that direction at 12 number of bars at 100 mm. So go to display and show slab design. Now go for typical layer B. Everything is okay, and here I will provide it for 100 mm and maybe for 140. Apply, close, and now you can see everywhere I'm getting 0, right? So this is how you can design isolated footing. Now let me know any query. प्रैक्टिस करना पड़ेगा मगर आपको.
Yes, sir.
हेलो.
Yes, sir.
या थोड़ा ये अगर आप में से कुछ लोग अगर यूज करते होंगे तो शायद उन्हें पता चला होगा. But this is exactly how you can provide reinforcement in that. And now if you use the same data for Excel sheet, you will see that Excel sheet will give you a conservative design or maybe some. But this is entire design is based on finite element analysis, and whatever design formulas that we are using, those are those are say approximate formulas or whatever that based on mu, whatever ast equal to whatever you draw it as a design of slab. But here you are getting more say detailed analysis because it is using finite element analysis. That's why you can always see that the reinforcement that you are getting through this finite element will be lesser than whatever you are calculating with the help of your Excel sheets or manual design calculations. So that is the advantage. बट इट विल बी समवेयर इट ऐसा नहीं होगा कि वो एक्सेल सीट आपको जितना एरिया दे रहा है उसके हाफ में ये कर रहा है, ऐसा नहीं होगा. देयर विल बी 5 to 10% डेविएशन ऑफ एक्सेल सीट रिजल्ट्स एंड दिस सेप रिजल्ट्स. यस, तो आपको थोड़ा वो प्रैक्टिस करना पड़ेगा. But I hope now you know how to design a footing with the help of Excel sheet, with the help of RCDC, and with the help of SAFE. Clear?
Yes, sir.
Clear, sir.
Yes.
Any doubt? अगर कुछ पूछना चाहते हो तो पूछ लो. Otherwise, we'll conclude today's session, and in next session we'll go for design of combined footing. Then we'll go for design of mat foundation or raft calculation. All that will go one by one. Yes, any query, particular
No,
query
sir.
if you have. Yes, Avinash.
Yes,
कर
sir.
रहे हैं ना?
सर एक क्वेश्चन था, इस सेप से नहीं, ई टाइप से रिलेटेड था.
हाँ, पूछ लो.
सर वो डिफरेंस आ रहा था उसके अंदर, स्केल तो डिफरेंट आ रहा था. दोबारा स्केल मैंने किया तो उसमें डिफरेंस आ रहा था सर. अर्थक्वेक एक्स और आर एस एक्स में सर वो डिफरेंस आ रहा था 10 डिजिट का. वो उतना चलेगा सर?
नहीं, see, scale factor for earthquake in X direction and scale factor for earthquake in Y direction will be many times different. They are not going to be same. The first
सर
thing.
वो डिफरेंस ज्यादा नहीं था, लगभग 10 डिजिट का डिफरेंस था. तो
नहीं, ठीक है ना, that is okay.
ओके सर.
उसमें कोई गलती नहीं है. Because see, earthquake calculation, base shear for earthquake vibration in X direction and base shear for earthquake vibration in Y direction, they are totally different because your configuration, entire thing depends on your configuration. So ऐसा कोई ये नहीं है. See, if you are having both dimensions approximately same, then you will get approximate same results. But if you are having a longer dimension in one direction and a slender dimension in other direction, then your scale factors are definitely going to be different.
ओके सर.
Yeah. Yes, anybody?
Excuse me, sir.
Samir.
सर वो
Yeah.
ई टैप्स का सर, वो जो आपने प्रैक्टिकल प्रॉब्लम अविनाश जी को दी थी ना सर, वो उससे एक डाउट था सर. वो
हाँ, बोलिए ना.
उसमें सर जो आपने वो ऑटोकैड का प्लान दिया था, उसमें सर एलिवेशन का नहीं दे रखा था, हाइट वगैरह या वो, तो वो खुद से एज्यूम कर लेंगे सर?
नहीं, वो जो नहीं दिया था, नहीं, वो जो नहीं दिया था वो एज्यूम करना है, क्योंकि आर्किटेक्ट ने भी मुझे नहीं दिया था. वो बोला सर आपके हिसाब से कर लो.
हाँ, वही पूछ रहा था सर. और उसमें एक चीज और पूछनी थी सर, जो पोजीशन ऑफ कॉलम है वो सर, मतलब वो फिक्स है, ओरिएंटेशन बदल सकते हैं, या फिर कॉलम जो उसमें कॉलम की पोजीशन है वो फिक्स रहेगी फिर?
नहीं, अगर आर्किटेक्चरल कोई प्रॉब्लम नहीं है तो यू कैन चेंज द दिस ओरिएंटेशन. दैट इज नॉट अ इश्यू. ऐसे ही मैंने वो जो आपको दिया था ना, वो एक्सरसाइज करके देख लेना है. आप चेंज करके देखो ना, कुछ फर्क पड़ता है क्या?
नहीं सर, वो पोजीशन की पूछ रहा था. ओरिएंटेशन तो सर वो तो आपने बताया था कि आप चेंज कर सकते हैं. वो कॉलम की पोजीशन पूछ रहा था सर कि वो फिक्स रहेंगी जो उसमें ड्राइंग में दी है?
नहीं, ऐसा कुछ नहीं है, ऐसा कुछ नहीं. उससे अच्छा अगर आपको सॉल्यूशन मिलता है, यू कैन गो फॉर दैट आल्सो.
सर कॉलम साइज डिक्रीज होगा सर अप्रॉक्स 50 mm के आसपास. मैंने एक्सेल पर उसको करके देखा था, तो वो 50 mm के आसपास वो डिक्रीज होगा कॉलम साइज.
50?
हाँ सर.
नहीं, वो तो वो साइजेस मैंने आपको ईटैप का मॉडल जनरेट करने के लिए दिए थे। मेरा ये कहना है कि बेस्ड ऑन योर ईटैप रिजल्ट्स you have to rectify all the sizes, and even sometimes you might need to add one more column. और एक्चुअली हुआ भी वही। वो 1 महीने के बाद उसने वो प्रोजेक्ट में थोड़े चेंजेस करके मुझे वापस भेज दिया कि सर जरा वो कॉलम का पोजीशन थोड़ा गड़बड़ लग रहा है, मेरा पार्किंग हो रहा है। मैं बोला भेज दे बाबा, मैं देख लेता हूँ। तो सी, इन सिविल इंजीनियरिंग नथिंग इज फाइनल। और मेरा सॉल्यूशन से अगर आपका सॉल्यूशन अलग है ना, इसका मतलब आपका गलत हुआ ऐसा नहीं। शायद मेरा भी सही है और आपका भी सही है, क्योंकि nobody knows the exact things. So we are providing the design based on our experience. Someone else might provide better design than you, or someone might provide worse design than you. वो तो सब है, ऐसा कुछ नहीं है कि, और
सर
सब कुछ।
कैटेगरी ऑफ सॉइल क्या था सर उसके अंदर,
या
आपने जो एनालिसिस किया? कैटेगरी ऑफ सॉइल मीडियम, हार्ड या
वो मीडियम सॉइल।
मीडियम सर? ओके सर।
या मीडियम सॉइल को कर लो।
और सर वो किस रीजन में है सर? वो अगर
पुणे रीजन
पुणे
में।
सर जोन 3
पुणे
में
तो
आता है।
वो तो हाँ, यही कंफर्म करना था सर।
पुणे रीजन जोन के लिए है ना।
हाँ
हाँ
जोन
यस
3।
सर, वो
ऐसा कुछ नहीं, you can assume that it is in zone number 5, and for zone number 5 I need this much. ऐसा कुछ नहीं, you can assume anything.
ओके
See,
सर।
हम लोग वो किसी को सबमिट नहीं करने वाले। हम लोग उस पर डिस्कस करके हमारी आइडियाज क्लियर कर रहे कि ऐसा भी हो सकता है या वैसा भी हो सकता है।
यस सर।
Excuse me, sir.
चाहिए तो मैं आपको और 2-3 भेज सकता हूँ।
हाँ सर भेज देना मुझे,
आपके
मैंने उसको
आप,
किया था।
आपके आपके एक्सपीरियंस के लिए
हाँ
कि
सर हाँ।
हाँ, तो सो एक्चुअली उसमें से कुछ काम हुए भी होंगे वो 1-2 साल पहले, तो मैं वो ड्राइंग भेज सकता हूँ आपको। अगर आप लोग काम कर रहे हैं, यू कैन ऑलवेज आस्क मी, इवन इफ आफ्टर फिनिशिंग द कोर्स ऑल्सो।
यस सर।
या
आप
तो
सेंड कर देना सर मुझे,
यस
आप मुझे सेंड कर देना 2-4 फाइल सर।
यस, बाकी ग्रुप को दे दो फिर।
हाँ मैंने वो
यस सर।
ग्रुप में डाल।
यस
अविनाश भाई सेंड कर देना आपने।
हाँ ओके।
यस, मैं अविनाश जी को भेज देता हूँ। वो आपको सबको वापस दे देगा।
यस सर।
हाँ, बट डोंट सी, मैं आप लोगों को यही कहूंगा कि जो आपका एनालिसिस है वही सच मानना है। उसमें अगर गलती है तो किसी को आप चेक कर सकते हो कि भैया देख लो, मगर ऐसा कुछ नहीं है कि किसी और ने आपसे अलग डिजाइन दिया है मतलब आपका डिजाइन गलत है, ऐसा कुछ नहीं। डोंट बी अंडर दैट इम्प्रेशन। हो सकता है मुझसे भी आप अच्छा डिजाइन कर सकते हो, कुछ चीजें मेरे समझ में नहीं आई वो आपने यूटिलाइज की, एंड यू प्रोवाइडेड अ बेटर सॉल्यूशन, बट दैट डजंट मीन दैट माय सॉल्यूशन इज रॉन्ग। क्योंकि रॉन्ग और सही ऐसा कुछ नहीं होता इसमें। हाँ, यू कैन से सर आई हैव प्रोवाइडेड बेटर सॉल्यूशन देन यू, वो हमेशा हो सकता है।
ओके सर।
या
Excuse me, sir.
या
Sir, in this foundation, if we have overburden, means we have overburden weight for soil, and if we account groundwater in this depth, then how we can include that in this design?
Okay. Yeah, you want pressure head that due to the water head, it is upward pressure that has been applied. You
Yes,
want that. So
yes, uplift. Yes.
mostly that is happening in case of mat foundations or strap that flat slab at raft calculation. वहां पे वो अपलिफ्ट प्रेशर ले लेते हैं। आइसोलेटेड फुटिंग के लिए अपलिफ्ट प्रेशर नॉर्मली नहीं आता है। अगर वो isolated footing है तो mostly there is a chances of getting uplift pressure is very very less, because the water is free to move in other directions. So water doesn't waste time to force the footing up. वो किसी दूसरे साइड से निकल जाता है. When
Meaning in between the spaces it will go and
yeah. So for isolated footing, there is I don't find any situation where you have to design a footing for upward water pressure.
Okay,
When-
sir. So when we will study this raft foundation, we will count it.
Yeah, definitely.
Okay.
There will account the upward soil pressure also.
Yes, okay. And about the overburden weight of this soil, we what we say for that?
Okay, that
Overburden.
overburden you can consider based on calculation, and then you have to apply that overburden pressure as a UDL.
Okay.
Yeah, that will act as a UDL. But see, that overburden will reduce your bending moments. So see, the bending moment due to the upward soil pressure, your footing is getting cantilever bending action, and that bending action is prevented due to the overburden. So
Okay. Yes, sir. I got it. Yes.
yeah. So if you do not consider upward pressure, then you will be on safer side.
Yes, sir. Correct. Yes.
Yeah. See, common, always I used to discuss with everybody that civil engineering is just a common sense. ऐसा कुछ नहीं है कि you don't have to analyze everything to exact analysis. आपको approximate analysis मिल गया जो safe है, that is okay. We got the solution. See, safe होना बहुत जरूरी है, rather than economical and very near to exact. It should be sustainable, it should be safe, it should be workable, and it should be having a durable. A solution must be a durable solution.
Yes, sir. Sometimes we have this underground water tank coming
Yeah.
over some area for this foundation also. Sometimes it happens also, sir.
Yeah. See, in that case, see, for water tank, if you are going for underground water tank, then you have to consider when the tank is empty, the pressure will act from below, and when the tank is full, the pressure will act from above. And for both situations, you have to design, and that's why in underground water tank, you see a reinforcement at bottom as well as at top.
Okay.
Most of the time, isolated footings are having a reinforcement at bottom only, except when the depth of footing exceeds 1000 mm. Only then we are providing reinforcement at top. Otherwise, for all footings which are having depth of foundation or depth of footing less than 1000 mm or 1 meter, we do not provide any top reinforcement at all.
Okay, sir.
Yeah. Okay, then with this, we'll conclude today's session, and we'll go for combined footing in next session.
Okay, sir.
Yeah.
Okay, sir. Thank
Okay,
you, sir.
Thank you.
Good night,
Next,
sir.
Nice, sir.
Good night, sir.
Good night. Good night.
Thank you, sir. Good night.
Good night.